Are we on? We are live and in person. Okay, good. Now, so, the third video in the series is going to be completing the worksheet. Clear? And there it is. So let's just go over it quickly. And there's 4 or 5 aspects that I want to go over and draw your attention to. Okay? Clear? Okay. Now, the way I have this again, if you're watching this for the first time, is going to be scale 1, 2, 3, 4, 5, 6, 7, 8. I have it labeled A through F, 3 on each, G through L, a little down, up, right? And then M through R, and then S through X. Is that right? Okay. Now, the first thing you do, very important, is you do the uncertainty. We call it uncertainty, or we do it, what do we call it? We call it uncertainty, or, starts with a P, precision. Okay, don't be afraid to shout it out, okay? Now, so it's going to be uncertainty or precision. We have to do that first. It's a good exercise. Now, how do you find the precision? Now, you find the precision by saying what? Anybody want to help me out? How do I determine the precision? Anybody? Nobody? Late in the day? This is how they all look at me. Okay? I'm going to wait. How do I do precision? Shall I give you a hint? Yes, Zayed, you want to say something? You had that expectant look on your face. Like you were surprised you were going to actually answer the question. I like that.
By measuring?
By measuring. Okay, I'll take that as a part of the answer. By measuring. I like that. Measuring. How do you find the precision? Well, it's sort of like measuring because you have to read a number, right? You have to read a number. This is, for instance, this is 40, and that's 50. I'm going to go 40, 50. Question, yes or no? Are they the largest, are those two, 40 and 50, are they the largest graduations on that scale? All right, now I go 40 to 50. What's changing? What number is actually changing? What place value is the number in that's changing? What is it? They said tens. Excellent. Okay, now. So you're close. Now, what's the actual precision? How many place values less than the place value represented by the largest graduation? 2 less. What is it? 8? Is that what you said to me? 8? Okay, I know it's after lunch. And you just ate. Or it could be the number 8, but let's do it again. You ready? Okay. All right, wait a second. We can do this. I have valves on my head that adjust the heat in my brain so I can control the flow of energy to answer the question more effectively. Okay, so I have to, it's kind of like playing a musical instrument. Okay. I got it. Okay, I'm there. Wait, I got it. I can do this. The largest graduation is represented by tens place. I have 2 place values less than tens place. 2 place values less than the place value represented by the largest graduation. So what is 2 place values less than tens place? Tenths, right? Because it goes 10, or let's say thousands, hundreds, tens, ones, tenths, hundredths, thousands, etc., right? So if I'm at tens, ones, tenths, right? That's the uncertainty. It's going to be 0.1. Clear? How do I do number 2? 0.01. Where did I get that? I have 4, 5. I have ones place. What's 2 less than ones place? I mean, the answer's on the board, guys.
Hundredths.
Hundredths. I like that. I heard that lisp. Excellent. Excellent. Okay. Hundredths. Okay. Here's number 3. Hundreds. 2 less than hundreds. Ones. Tenths is 2 less than hundreds. Who said tenths? And that's okay. Do you understand? Do you know why you said tenths? That's okay. See, the whole world, logic is predicated upon making a mistake. If you don't make a mistake, you're not using logic. You may be using logic, but you're not sure if you're using it because you haven't made a mistake yet. Trial and error, direction, yeah. Excellent. So this is going to be tenths, thousandths. This is going to be 10,000ths. 10,000ths. Wait, I can do this. Well, hold it. You count. All right. I'm going to start with ones, and then I'm going to do the graduation. You tell me when to stop. You ready? Okay. Hundreds, tens, ones, tenths, hundredths, thousandths, 10,000ths, 100,000ths, millionths, millionths. So 2 less than 10,000ths is millionths. I wasn't sure what I was going to say. Did you see that? Millionths. Okay? Get it? So this would be millionths. Clear? I mean, unless you're using some of the most sophisticated measurements on Earth, you're not going to be using that. You know, that would be like finding the average temperature of the universe. You know, that's going to be very, 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 very exact. And you're not quite sure what I mean by that, but you will. Remind me. Whoever reminds me of this moment in time, when it's obvious to you, I'll give you extra credit, okay? Excellent. Now, where are we? This one? Getting easy now? Ones, hundredths. Thousands, tens. Tens. What, did somebody say once? It's been a long time since somebody said that. That's okay. You know what that's called? That's called it's late in the day. That's what that's called. I want you to know that. That's called late in the day. Okay, excellent. So this is going to be tenths. Yeah, okay, good. Now, there's a few things that I want to show you here. For instance, look at this. What does that 0 mean? What does that 0 mean? What does that 0 mean?
Hundredths.
No. It means ones. I mean, it's in ones place. Not sure what to do with that answer.
Oh.
Is it late in the day?
Yeah.
Yeah, okay, that's all right. There's a lot of late in the day going on in here, and that's okay. Late in the day, first full day. You should have seen me first period. I mean, look at the way the thing is numbered and lettered. It's like all over the place. Yeah? I can hardly speak this morning. Okay? So that means that see that where that 5 is? That means that that's exactly on that line, doesn't it? Doesn't it? Means it's exactly on the line. So it's going to be 450. Yes? Now, how do I know? Does that 0 have a function? What's it doesn't?
It does.
Well, what's its function? The function is very simple. Don't try to look too deeply here. The function of that 0 is actually very simple, but does it have it does have a function. You're not sure what that function is. I can tell by the look on your faces.
Without it, it wouldn't be under.
No, you're getting, that's simple, but that's even too complicated. What's the function of the 0?
0.
1. It's a placeholder.
No, it's not a placeholder. No, it has a function. That's too simple. This 0, all right, let's do another one. Let's say, what's the function of that 0? What's the function of that 0? What's its function?
It's 10.
Say it's on
Who said that? What's your name?
Victoria.
Victoria, what did you just say? Now say it loudly with ownership, like you're proud of it.
To say that it's on the point, it's only the
Yes, excellent. Don't jump. Yes, that's exactly on that line. That's what the function of that 0 is. Oh, I did something right today. Excellent. That's exactly what it means. Now let me tell you something. The hardest parts, one of the hardest parts of this whole unit is going to be determining the difference between a 0 that has a simple function and a 0 that's just a placeholder. A 0 that has a simple function is very significant. That, I just gave you away an enormous concept. What I just said. What did I just say? A 0 that has a simple function is, you don't remember?
To show that it's...
No, what is it? What did I say? It is, what's the adjective I just used? Is that an adjective? You know why I need to know that? Because I have the director's son, and the director may be watching this, so I can't be grammatically incorrect. Although the director just saw me do that. Is it? What did I just say? I said, what did I say? I said that, what? A 0 that has a simple function is significant. Correct? Didn't I say that? That is huge. Huge. Believe me when I tell you, it is huge. Okay? A 0 that's just a placeholder, is that significant? Absolutely not. Clear? You think I meant an adjective, right? It's actually, I meant a noun. That 0 means that that line is exactly on that 5. It is an estimation. In your best estimation, you are saying that that measurement is exactly on the 5. Not a little above it, where it would be a 1 or a 2, but right on that line. Isn't that what you said? Yes! Excellent. You get it? Yes or no?
Yes.
Wake up! That's it! Okay? Now, let's go back. Does that 0 have a function?
No.
Does it have a function? It's the same function. It's saying this is going to be hundreds place, this is tens place. That 0 is saying that's tens place, right? 5, right? Tens place? That's where it is, tens place. That 0 is saying that that line is right on that 0. Right on that 0. First down. That's it. Do you get it? Yes or no?
Yes.
You don't look in the slightest bit excited. I mean, I'm like having fun up here, man. This is really cool. I know, I don't get out much. I know, but whatever. Do you get it?
Yeah.
That's the hardest part. What I just said is the hardest part about this particular lesson. Determining whether or not A 0 has significance or not? Okay? Does it have a simple task, or is it just a placeholder? Okay? Is that all right? Okay? You see these zeros here? They're just placeholders. They're making sure that that 5 is millionths. You understand? If I didn't have these placeholders here, that 5 wouldn't have a place value of millionths, and everything would be completely screwed up. What place value do all of the digits have to have? The far digits to the right. What place value must all the digits on the far right have to have? Millionths. You look at the precision. Do you get the connection between the precision? Do you get the connection between, Mr. Paz, do you get the connection between the precision and the place value that the digit on the far right has to have? Do you get it? Do you get the connection? These are all millions. These are all tens. What? These are tens? No, that's not tens. That's not tens. That's tens. Well, what's that bar mean? Forgot to mention this. What's the bar mean? Well, what must be the precision of all of these? That 5, what must they be? What must be the precision of all of these three values? What must be the precision, Mr. Paz, of all three of those values? Tens, right? Easy? Makes sense? Excellent. Well done. However, how do I denote that is exactly on that line? That's exactly on the 5? That 0 with the bar over it, does it have a function? Does it have a simple function? Yes or no? The 0, this 5, that line is right on that 5, right? That's the 5th gradation, yes? Yes? What is telling me that red line is exactly on the 5th gradation represented by the 5? What is telling me that the red line is exactly on that black line? Isn't it that 0? Does that 0 have a simple function? Yes or no?
Yes.
Well, the way that we denote that it has a simple function, we put a bar over it. That's what we do. Systems International. It's a worldwide agreement among scientists for the recording and manipulation of data so that we understand each other's results and we can replicate not only the experiments but the results of each other's work. Wow, that was one breath. That was pretty good, wasn't it? Was that all right? You get it? But if we're all governed by different rules, how many people have ever been in a class where you measure it and everybody has a different amount of numbers that are representing a measurement? Raise your hand. Yeah. Everybody. Exactly. We have to come to an agreement. This is a pure science. In a pure science, Salama, we do experimentation. Experimentation produces facts. Those facts are defined by numbers, correct? Masses, lengths, volumes. They generate numbers. Those numbers have to be manipulated. Mass divided by volume equals, sound familiar? Density, correct? So we're going to manipulate numbers. So if we all have different numbers, aren't the answers or the manipulations, the mathematics going to be completely screwed up? Aren't they going to be? If you're in Kazakhstan and you're in Canada and you're doing the same research but you have different rules for measurement, yet you're doing the same experiment, can you really compare the results? Can you? Absolutely not. So we've got to come to some kind of agreement, and that's what we're doing here. So when I say you put a bar over it, that's not a Darcy rule. There are no Darcy rules in here. This is Systems International. What is a subset of Systems International? Does anybody know? It starts with an M and ends with a C, and you've been using it your entire life, unless you're an American. What's it called? What system? Metric system. The metric system is part of System International. Do you get it now? And this is part of System International. Now, you have got to be able to denote a zero that has a small special function. And that is, the function here is, the function here is, the function here is, here is, here is, here is to tell the scientist in Canada or Kazakhstan that it was right on that line. First down! Got it? Get it? Good. You understand? Do you understand? Now, here we go. You ready? Everybody pound on their table as if they are giving a drum roll. Commence now. Keep going. Any number read from a scientific instrument is called a significant figure. You get it? These are significant figures. These are significant figures. How many significant figures here? 3. How many significant figures there?
3.
How many significant figures there?
3.
How many there?
3,
How many there?
3,
How many here? Be careful!
3.
Be careful! 3. Extra credit, 10 points right there. She did it. Right? Because these zeros don't have that special function. She made the connection. You see? A zero that has, didn't I say to you before, the adjective that describes that zero that has that special little function is called, that zero is significant? Right? That was the adjective. But there's a noun called significant figures. That zero is a significant figure. It is a thing. It's a noun, man. It's a noun, Jack. Feel it, read it, do it. Got it? Good. Yes or no? Is that zero to the right of the zero with the bar over it, is that significant?
No.
Absolutely not. Not. No way, Jose. Got it? Are you sure? Now, we're done. End of part 3.